Hey scholars, you'll notice you have a Trig Identities Part 2 assignment for today. The first page is really similar. We have all the trig identities that we're going to be using in all the different forms. Notice here that you have your Pythagorean theorem, trig identity, cosine squared theta plus sine squared theta equals 1. That has just been rewritten over here as well. It's been solved for sine squared theta, which you did yesterday in your homework. So you should have gotten some of these as your answers. So let's come on down here to section 1 is going to be to use the trigonometric identities to write each expression in terms of a single identity or a constant, right? A constant being like the number 1 or the number 0 or any other number. I'm going to go over a couple of these with you, and simplifying fractions is going to be extremely helpful. And then we're working up to section 3, which is verifying identities, and we want to show that this is actually true. It's kind of like a little mini proof. You are proving that this is always true using the identities that are provided. So let's start up here with section 1, number 1. I have my trig identities sitting over here for me. Okay, so section 1, number 1. And the directions are simplify. So what I'm going to do is I'm going to look over here at my identities, and I'm going to see if there's anything that relates sine and cotangent, which I see my cotangent is cosine over sine. So that's going to be my trick. So I'm going to rewrite the cotangent as cosine over sine. And this is still times sine theta. And this sine theta is just over 1, right? If I wanted to write it as the fraction, then I can see it over 1 with these two being multiplied. So now it's really obvious. The signs cancel, and I am just left with cosine. And there we go. Done. Let's try from section 1, number 5. Number 5 is secant theta over tan theta. And let's see, to simplify this, I'm looking over here again at my trig identities. Like this. And I'm trying to relate something to, I don't know, like maybe I want to look at secant. Secant is 1 over cosine. So let's see, tangent is sine over cosine. Ooh, this might work. Here's what I'm going to do. I'm going to break these. Secant theta is on top. I'm going to put that over 1. Tangent theta is on the bottom. So I'm going to put that on the bottom. And I'm just kind of breaking these up separately so that I could like kind of see them a little bit, right? So now tangent, I'm going to rewrite tangent. Oh, and you know what? I'm going to rewrite secant as well. Where was that? Secant is 1 over cosine. I bet that's going to work out. So secant is 1 over cosine. And this is still like all over 1. But that over 1 doesn't really change anything, right? Because anything divided by 1 is still itself. So this complex fraction is just going to like chill. But then 1 over tangent. Tangent is sine over cosine. So this is 1 divided by all this stuff. Remember, dividing by a number is the same as multiplying it by its reciprocal. So just a little side work to just show you how this works out here. 1 over sine theta cosine theta is the same thing as this fraction on top, which is like 1 over 1, just 1, right? 1 over 1, instead of divided by this number, multiplied by its reciprocal. So the reciprocal of this is just it flipped over. And this thing times 1 doesn't change anything. So this basically just gets flipped. Oh, so pretty. So pretty. And then cosines go bye-bye. And this is 1 over sine. But 1 over sine is cosecant. So I'm going to rewrite this as cosecant theta. And I'm done. So awesome. It's so pretty. It takes a little bit sometimes to figure out which ones you're going to use, but it's kind of like a little puzzle. All right, let's do one from section 2 of the homework. This first one that tells you to like factor, right? A squared b. Don't overthink this one. You're not going to get two things like this, like you're used to with the plus or the minus or whatever. You can only pull out what both terms have in common. So just pull that one thing out of what both those terms have in common. Okay. Now we're getting into verifying. So they want you to verify that this is true, that this thing equals 1. So here's the trick with these. What I like to do personally is I like to only work on one side of the equation and get it to look like the other side. You can work on both sides of the equation to get them to equal each other. Like this 1, I could rewrite as sine squared theta plus cosine squared theta, and then try and get something over here, like all this stuff to pop out as also being sine squared theta plus cosine squared theta. But in general, what I found for me is that it doesn't tend to work as well, right? So I don't know, play around. I think, trying things and having them not work out very pretty the first couple of times is good practice. I'm just going to stick to working with one side, manipulating one side and moving it through. I just want to get all this stuff to equal 1. And I see a sine and I see cotangent and secant theta. Secant theta is like cosine. So I don't know if that necessarily helps me with sine. I know every time I see tangent, I always think tangent involves both of them, which is really, really handy. So cotangent is, like we saw before, this thing flipped over, right? It's cosine over sine. So I'm going to start there. So cotangent is cosine over sine, and already I see that this sign is going to cancel. And again, I didn't write these over 1, but you can put them over 1 to keep all the fractions accounted for. These signs go bye-bye, and now I just have cosine theta, secant theta. Still equaling 1. Okay, so now this is looking really good. Secant, oh, look at that, so pretty. Secant is 1 over cosine. Oh my gosh. And again, these cancel, and I am left with 1 equals 1. I like to put little check marks. You could, lots of mathematicians still use this. QED, it is Latin for, oh, now I'm gonna mess it up probably. Quod erat demonstrandum. It means what was to be proved or what was to be shown. So done. It's glorious. Let's do one more. All right, so now we have this one that we want to prove. And I'm just like looking at my trig identities here. And what do I see? First, I'm like, which side do I want to work on, right? I don't know. I'm just gonna work on this side. I don't think it really matters which side you choose, but I'm gonna work on this side. That's gonna be my side. And then I see, like, I don't know about the 2. I definitely probably don't want to rewrite this 1 as like a bunch of other stuff. I'm just going to focus on this cosine squared theta. So this guy right here, I have this Pythagorean identity rewritten as 1 minus sine squared theta. So I'm just going to like rewrite this. Now be careful because this is being multiplied by a 2 there. So 2 still is going to be multiplied by everything that cosine squared theta is. Okay. So cosine squared theta is 1 minus sine squared theta. And I'm going to get rid of these parentheses by distributing this. And oh my gosh, I totally see it. I have this -2 sine squared theta that I want here. And then I just need a positive 1 to go with it. And 2 minus 1 is 1. And they are equal. Oh my gosh, Q, E, D. Done. I'm so happy. It's lovely.